Hello, everybody. This is Mr. Mercier. Today we are going to be learning about two things that you already really know about: parallel and perpendicular lines. Okay, we've talked about that a lot this year. We've had a lot of different sections using parallel and perpendicular lines. So just a friendly reminder. Okay, so parallel lines, they never intersect, and they're always going to be the same distance in between these two lines, right? And remember how to mark up two lines being parallel. We put these little arrows on it. Now, perpendicular lines are always going to meet at four 90-degree angles. Remember, the symbol for 90 degrees is this little box. Okay, now what we're going to be doing that's a little bit different, if you've noticed we've been graphing a lot of lines, we're going to be putting these lines on a coordinate plane. Okay, a coordinate plane is a XY thing that we did a lot in Algebra 1 on. Okay, now the relationship between parallel, okay, the slope kind of tells you how steep a line is. If two lines are parallel, then they're going to have equal slopes. So like on this is an example of two lines that have equal slopes, two lines equal slopes, two lines equal slopes. Now perpendicular lines are going to have opposite reciprocal slopes. So that's like negative reciprocal slopes. So the first example is 1 over 3. Now the reciprocal just means I'm going to flip this fraction. So instead of 1 over 3, I'm going to make it 3 over 1. Okay, so those are called reciprocals. Now a negative or an opposite reciprocal is one of them is going to be positive, one of them is going to be negative. So like 5 is going to go with negative 1/5. So negative 2 over 7. So if I flip that, it's going to be 7 over 2, and it's going to be positive. Now, back to Algebra 1 to find out a slope. Okay, that's the slope equation, y2 minus y1 over x2 minus x1. Okay, and you did that a lot in Algebra 1. You might have called it constant rate of change or slope. Okay, and we use the letter m because of the equation y equals mx plus b, which you guys have been doing a lot with your inequalities lately. So how do we find the slope, okay, between two lines? So we're just going to use that equation, right? We're going to use the formula y2 minus y1 over x2 minus x1. Now, what's x1 and y1? So we're going to, since this comes first, this is going to be x1. The 3 is going to be y1. The 6 is going to be x2. And the 4 is going to be y2. Okay, now we're just going to plug that right into our equation. So it's going to be y2 minus y1. So 4 minus 3 over 6 minus and negative 1. So whenever you have two negatives together, they become positive, right? So this is actually going to be 6 plus 1. So I get 1/7. Now on a graph, how you can figure out the slope, okay? Now, two ways, okay? You can count your boxes, right? I know you did some of these slopes. You can thank your wonderful Algebra 1 teachers from last year, where it's gonna, you have like a rise over run. So one way to figure out what the slope is, you can just count these boxes. So for this one, like you're gonna, so I start from 1 point and I went up 3 and I went over 2. So the rise is positive 3 and the run is positive 2. So the slope is just going to be 3 over 2. The second way would be to figure out what these ordered pairs are, right? The x comma y for both of them, and then just do y2 minus y1 over x2 minus x1. So these two ordered pairs, the first one is 0 comma 1, the next one is 2 comma 4. So I'm going to do y2, which is 4, minus y1, which is 0, and then I'm going to do 2 minus 0. So the slope's going to be 3 over 2, the same thing that you just got on that last page. All right, now the first couple slides, on the second slide, I showed you this, right? So what we're going to be doing is we're going to be looking to see, are the slopes the same? Because if they are, then they're parallel. Or are they negative reciprocals of each other? Meaning that you flipped your fraction and you've switched the positive to a negative. Okay, so just to make sure you guys are watching the videos, right? So the verification word is Lucy. Okay, I picked this. That's my dog Lucy and my son Andrew. Every day he has 20 minutes of reading that his third grade teacher has assigned, and usually he reads the story to Lucy. Lucy's 12 and she just had surgery this week. She was having trouble breathing, and a couple of the flaps in her throat she's getting paralysis in, so they had to tie one of them back. But she's doing much better. All right, so the example, y equals 3x plus 2. Okay, so the question is that going to be parallel to y equals 3x minus 5? So y equals mx plus b. M is the slope, b is the y-intercept. So the first line, the slope of that's going to be 3 because it's the number in front of the x, and the slope of the second one is going to be 3 because it's the number of the x. So both of the slopes are the same. So if you look at this graph that I pulled on Desmos, okay, these are parallel. The distance in between these are always going to be the same, right? And they have the same steepness where I'm going up 3 and over 1, right? All these, I'm going up 3 over 1. Next one is y equals 3x perpendicular to y equals a third x minus 1. Okay, so if I look at the two slopes here, I have this one is 3 and this one is a third. So yes, 3 is the same thing as 3 over 1. So if I flip that, I would get a third. So they are reciprocals of each other, but they're not negative reciprocals because both of them are positive. Okay, and if I look at the two graphs of these, the red one's 3x, the y is 1/3. The angle right here is definitely not 90 degrees. So they're not perpendicular. They intersect, but they're not perpendicular. Now let's look at a different example. So let's say I just put a y equals negative 3x. Is that perpendicular to a third x minus 1? So the slope of the first line is going to be negative 3, right? Because that's the thing in front of it. And the slope of the second line is going to be 1/3. Now we're trying to figure out if these things are parallel or perpendicular. We don't really care about the y-intercept. Okay, so the only thing that we're really going to care about is the slope, because that tells me the steepness. Eventually, as long as they're not parallel, they're going to cross. So we don't really care where. We just want to know if this is 90 degrees. So negative 3 and 1/3 are negative reciprocals of each other. I didn't write it out, but negative 3 is the same thing as negative 3 over 1. So you would flip the 3 over 1 to make 1 over 3. Okay, next example. Let's say that you have a line and you give them 2 points. So let's say line L, okay, goes through 1, 2 and 0, 4. And the second line 2 goes through 0, 0 and 1, negative 2. So are these two lines parallel, perpendicular, or neither? Okay, so what you need to do is you got to figure out what the two slopes of these lines are. So if I looked at it, I could do 4 minus 2 over 0 minus 1. And I get the slope of the first line to be negative 2. The second line, I'm going to get negative 2 over minus 0 over 1 minus 0. So again, I'm going to get negative 2 over positive 1. And these both end up being negative 2, so that means the slopes are the same, so the lines are parallel. Now you can also, if you want to do that problem a different way, okay, we can plot these points, 1, 2, 0, 4, 0, 0, 1, 2, and then we can just count the boxes, the rise over run. Okay, if they're the same, then they're parallel. If they're negative reciprocals of each other, they are perpendicular. So if I look at both of these and I plot these points, I look at this, okay, the first one I'm going to go positive 2, negative 1. So slope of that's negative 2 over 1. Or I could go over here where I go positive 2, negative 1. So these both are going to end up being negative 2. Okay, for our last example, okay, so let's look at this. Determine whether this line is perpendicular to this line. Okay, so a couple different ways you could do it. Okay, I am going to just kind of look at the points that we have. So when you're picking points to count the rise over the run, I would make sure you do points that cross at one of the intersections of the squares, right? So if you can see my arrow, don't pick right here because we're not really sure where that point is. Make sure you do it right at the intersection of those. So for the slope of line AC, I'm just going to count the rise over the run. So I rose 4 and I ran 2. So it's going to be 4 over 2, right? And they're both in the positive direction. Now for VD, I'm still going to do my rise over the run. So I'm going to rise 2, and then I'm going to run negative 4. Because I went to the left, this is a negative. So it's going to be rise 2, run negative 4. So 2 over negative 4 is the same thing as 1 over 2, or negative half. So 2 and 1/2 are negative reciprocals of each other. So that means that these two lines have to be perpendicular. Now, if I didn't want to count the boxes, I could always do my slope formula to get both of these the same answers. So, um, so keep up the hard work, everybody. All your teachers miss you very, very much. I'd rather be doing this in person and talking to you guys, but hang in there. Okay, only a couple more weeks left. Let's finish strong. Thank you.